In this video, I'm going to show you how you can have some fun with the Rigid Body Simulator in Blender by creating a wrecking ball simulation. So, open up a new scene in Blender, like this one, and delete everything. We're now going to replace that with a torus. Now, this torus is going to become the first link in our chain. So if we just go into edit mode, grab the top half and move it up, you can see it now looks like a link in a chain. And then if we duplicate that, move that up to there, rotate it by 90 degrees, you can see we have two links. And then if we just duplicate that once more and then hit Shift R, it's now just going to repeat our last action until we have a chain that is as long as we want, which is about that, really. Okay, so now we can get into the physics. So go ahead and click on any link, doesn't matter which, and go to the physics panel, and you can see we've got an option here that says rigid body. So go ahead and check that, and now we've got a whole bunch of options. Now, if you've never used rigid body simulation before, it's probably a little bit confusing. Don't worry. The only thing that we're actually going to change here is the shape of the collision. So by default, it's set to convex hull, which sort of sets like a semi-accurate sort of box around our objects. Now, because we're working with intersecting meshes, we need to set this shape to mesh, which is the slowest of the simulation, like baking types, but we need to use it because we've got intersecting meshes, all right? So we need to do that for all these links, okay? But if we were to do that one by one, it would be ridiculous, okay? But thankfully, in the toolbar, you've got something that's called Rigid Body Tools. And there's an option that says Copy from Active. So if we click that, all of these now have those same settings. Awesome. So if you hit Alt-A right now, you'll see that they all fall. Perfect. Now let's see how it looks if it collides with a ground surface, all right? So just add in a plane. We need to make sure it's part of the rigid body simulation. And the type, instead of setting it to active, I'm going to change it to passive, which is basically something that doesn't move, like a solid wall or ground. And look at that. Our chain is working perfectly, absolutely brilliantly. All right, now if at this point, if your chain is not working well, if it's sort of like exploding or anything like that, that's because you are using a chain that is too small. Blender does not work well if these are like tiny little objects like this. If I try and animate this, you can see that Blender sort of freezes up and the links come apart, and you can see it doesn't work well at all. So it needs to be fairly big in order for it to work. It's unfortunately not accurate to the real world. Like if this was set to the metric units, you can see that one chain link is almost 4 meters high. Ridiculous. Anyway, that's just one of the things, okay? So it's working well as a chain, which is great. So we want this top link here to be stationary, like to be anchored, so that our wrecking ball can swing. So if we go to the rigid body settings right here, you'd think that you might set this type to be passive like we did for our floor. But what you'll find is that the link disconnects. And that's because really passive is only used for things which are like an object is going to collide with it or it's not going to move. It's essentially not really part of the simulation. But if you instead leave it as active but uncheck dynamic, it means it still has like its active rigid body mesh collisions, but it remains the same, like it's not actually moving at all. So that way we get a stationary link and everything else is behaving like a normal chain, which is kind of cool. There you go, you can kind of play with it whilst it's animating. Anyways, all right, so now the chain is working well. Now we can go ahead and add in our wrecking ball. So down here, I'm going to go ahead and add in a sphere. Okay, and you can make this as big as you like. Something like that is pretty good. Nice big old wrecking ball. All right. Okay, and I want to, of course, move this up. And also at this stage, you want to reset the origin point. Okay, so reset it. And now the origin point for all of these links has it now dead set in the center. And the reason that's important is that the rigid body simulator uses the origin point as the center of gravity for that object. So it's very important that that is in the center of whatever object, otherwise you're going to get some weird results. Anyways, we've got the wrecking ball that's hanging. Let's see how it looks when it swings. So in order to get it to swing, what I'm going to do is position the cursor at the top of our chain there, turn on 3D cursor pivoting, and now if I just pull that back to about there and animate, we have a swinging wrecking ball. Yay! Everything is going fine. All right, now let's see if we can increase the mass of this wrecking ball. Now the mass is in kilograms. So if you actually turn on metric units, you can see that the mass is 1 kilogram, okay? I'm going to set this to 30, okay? I think wrecking balls in real life are a little heavier than 30, but in this case, let's just see it. Oh no, look at that. The chain has split, okay? And that's because essentially these links are too weak. They're too weak for this heavy object. So how do we fix that? Well, we essentially need to increase the mass of these links here. Now, the mass is going to affect, the force of things once it hits something, but it's also going to affect the strength of it. So if we increase this to, say, 4 kilograms, and then to make sure it applies to everything, select copy from active, you'll see that now the chain should not break. So that's something to keep a note of, is that the mass will not only affect how heavy it is, but also how strong it is. So something to keep in mind. Okay, cool. So it's swinging. Everything is fine. Now we can smash whatever it is we want. So I'm just going to check that the wrecking ball is not touching the ground, but pretty close, because I'm going to place some boxes right here. All right, this is the fun part. You can create whatever you want, whatever you hate, you can put right here. But cubes look kind of cool when they just sort of like smashed around. So I'm just going to add in a cube, and I want there to be a whole bunch of them. So I'm going to use an array modifier, okay? And it's important that you always just leave a little gap in between every object in a rigid body simulation. Otherwise, you'll find that they just like explode because they're like right next to each other, and it's a little crazy. So there needs to be a little gap. And I'm going to add in another array going in the opposite direction, or the Y direction, I should say. About that. That's pretty good. And then one more for the boxes vertically. Like that. Increase that. And there we go. Okay, so we got a whole bunch of boxes. Awesome. We could probably scale them down if you want. All right, that's pretty good. Now, of course, we need to apply these arrays, because currently this is actually only one little tiny cube at the bottom there. So apply all of the arrays in the order that you created them. And now each of these are its own mesh. But we need them to be its own separate object, not just one as it currently is. So if you're in edit mode, select everything and then hit P, and then you can select separate by loose parts. Now each one of those cubes is its own separate object. Cool. Now, we want to make sure that this is, of course, added to our rigid body simulator. So, simulation, rigid body, and let's leave it at convex hull. And we're going to set the mass of this to be, let's go 0.1. So that's about 100 grams. Yeah, it is exactly 100 grams. Okay, and then hit copy from active so that they all have the same settings. And now if you were to animate this, you'll see that happens. Oh no, what's happened? All right, the reason for that is that the origin point for every single cube is right down there in the corner, which is what I was talking about with the center of gravity. So you need to make sure everything is selected, then hit Control, Shift, Alt, C, and then origin to geometry. And now all the origin points are in the place that they should be. So now when you animate it, you have, ta-da, a wrecking ball going through some cubes. So one final thing to note is that everything is moving very slowly. Like if you look at the way these boxes are falling, it's really not behaving like gravity is. Like everything is going really, really slowly. And the reason for that is everything is huge. Like the size of this wrecking ball, let's see how big it is. It's like 10 meters high, okay? What's that, like a 4-story building or something? So it's ridiculously huge. So the simulation is actually playing at the right speed, but it looks strange at this scale. So of course you could fix that by scaling everything down, but then you'd obviously have problems with the simulation. So a way around that, I found, if you go down to the rigid body world settings here, you can increase this speed. So I find if you just increase that to double what it normally is, then when you animate it, you'll see everything moves a lot faster and it looks a lot closer to real life. So that's just some settings to play with. And also one final thing to leave on, if you wanted to bake this animation to keyframes, like if you wanted to send this off to a render farm, or for whatever reason you needed these settings, saved, embedded into the file, what you can do is, you can bake it. So if you just select everything and then go down to the rigid body tools, you've got an option here that says bake to keyframes. So if you click that, you get a little pop-up box here. Now this will take a while depending on your animation. So I'm just going to set the end frame to 100 and let's just see how it looks once it's finished. And there you go. So you can see it's changed color because these objects no longer have any rigid body data. It's no longer an actual physics object. But if you go to the timeline, you can see that every little object here has keyframes on every single frame. So that's really helpful, as I said, if you wanted to send this off to a render farm or something else, or if you had problems, rendering the animation, that's something that you can do. But anyways, that concludes the tutorial, guys. As you can see, just a little amount of work and you can get some really cool effects. This was really like a sort of a starting block for getting into rigid body simulations. So I'm looking forward to seeing what you guys create with it, what you smash and blow up. So if you create something cool, maybe upload it on YouTube and post the link in the comments. Anyways, that's all from me. Thanks for watching and see you next time. Bye.